Welcome, everyone, to another episode of the NXP EdgeVerse Techcast, your go-to spot for software, tools, and technologies for embedded systems. I'm Kyle Dando, and I'm one of your hosts, and I'm here to make sure that we break it all down in a way that makes sense, and at the same time, we have a little fun while we're at it.
And I'm Bridgette Stone, Kyle's partner in Tech Talk, bringing all the energy and excitement to the podcast. Just kidding, Kyle. I know you contribute. We're really excited to have you with us today. Whether you're tuning in on your commute, at the office, or just relaxing at home, we've got a great episode lined up. We're thrilled to have Brendon Slade with us today. Brendon is the director of the horizontal enablement team in the secure connected edge business at NXP. Now that is a mouthful. Welcome, Brendon. And fun fact for our listeners, Brendon and I like to joke about our matching BS initials. It's like we were destined to team up, and BS in the best way possible on today's episode.
Thank you, Bridgette and Kyle. It really is a pleasure to be here. I listen to the podcast. I've been a regular subscriber since it started, and I'm excited to be here. And yeah, I think for the engineers, the question is it BS squared or is it just BS split BS? So I'm based in San Jose, despite the British accent. Yes, I'm from the UK originally. So I've been in the semiconductor industry, about 35 years in various forms, so much longer than I care to admit. So as Bridgette said, I look after the horizontal enablement team, and that's really all about the kind of software and tools that every customer needs when they're using our microcontrollers and microprocessors. So very broad and very horizontal in terms of markets, and hence the name.
Excellent. Well, thanks, Brendon. So if you've chosen to listen to this episode, you're probably pretty curious to learn more about Zephyr. Well, you're in luck, because today we're going to focus on the Zephyr Project, and we're going to explore how it's having a growing impact in the embedded space. So Brendon, why don't we kick things off? Could you share what the Zephyr Project is to the listeners and why it's becoming more significant in the embedded systems landscape?
Yeah, certainly. So the Zephyr project is at its heart an open source real-time operating system designed for resource-constrained devices across various architectures. And while it's based on an RTOS, as I said, at its heart, it also comes with a lot of middleware and like networking, wireless communication, security, a lot of other different things that come as part of the whole package. It also has test infrastructure, and it even has specially designed build tools like West, which have been developed specifically to make it reach its full potential. So it's tailored for embedded systems. It's not from a desktop lineage. It's not a form of Linux like a lot of people seem to misunderstand. And it offers a scalable modular platform, which is suitable for applications ranging all the way from very simple sensor nodes all the way up to pretty complex IoT devices.
Okay, Brendon. So how is Zephyr differentiated from all those other RTOS choices that are available to the listeners?
Yeah, so anyone who's been in the embedded microcontroller space for 10 years or more will know that there's a whole host of different RTOSs that have been developed for various different reasons over time. And a lot of those continue to exist and are widely used. But what really makes Zephyr stand out at the moment is its momentum in the market, along with also the infrastructure and middleware enablement that comes with it. So the project's growing very quickly. Currently has 49 members, and this is made up of an interesting mix of not only semiconductor vendors like NXP, but also software companies and big OEMs in a lot of different markets. So we have automotive ones, we have compute space ones, we have industrial ones as well. Some very cool ones like Vestas, who make wind turbines. So bringing all of this together, you get a broad spectrum of suppliers and end product developers, meaning you get a very good eclectic mix and views of how we want to develop software together. There's also training companies and academic institutions in there as well that I should mention, companies like Doulos and AC6. And in addition to those companies, several contribute to the project without being members, and this can be other large OEMs as well. So the project is open to non-members, and that also contributes to the momentum it has.
So Brendon, NXP has been part of the Zephyr project for quite a while now. What made us decide to take our involvement up a notch and really deepen that commitment?
Yeah, we were a founder of the project way back in 2015 when it started. And Our decision to be involved really comes from the evolving needs of the customers in the industry. So as IoT and edge compute applications are getting more and more complex and sophisticated, there's a growing demand for flexible, secure, and scalable solutions. And Zephyr's architecture aligns really well with those requirements and their fundamental aims of what the project was created for. There were also signs of a momentum towards open source software for MCUs. The head of our MCU and MPU product portfolio at the time, Jeff Lees, was frustrated with the way we were having to invest a lot of effort in Bluetooth stacks when others already existed. He had the vision to see it was a much better to collaborate on these kind of things that are broadly used and spread the technical debt across multiple companies for common benefit. By intensifying our involvement, we aim to be one of the drivers of this innovation and help ensure robust support to our customer developer community by being focused on Zephyr. Our decision to help found the project is now proving to have been a really good bet because we have customers asking about Zephyr support on a daily basis.
Sounds like a pretty solid bet to me. I'm curious, beyond the customer demand, how is NXP contributing to the Zephyr community? What's your team's role in ensuring Zephyr's continued growth and shaping the project's future?
Yeah, so the obvious thing to do here is to contribute support for your all platforms, and that's important. Otherwise, customers don't have the choice to choose the silicon platform they want to run on. But we're also very actively contributing to a lot of other aspects of the project. This can include things like new driver definitions. We just have a request for comment out about distributed switch architecture right now. We have the lead of our test organization is also the chairman for the test committee. And we're constantly looking at areas where Zephyr has gaps or needs improvements and how we can help work together with the other members to do that. So this can span a wide range of different aspects of the project. There's other examples where we've seen strong demand for better low power management features, and we've worked there to help enhance Zephyr's capabilities, but also show the community how you can use what Zephyr can do along with other technology, which may be vendor specific, but you can mix the two together and still have a portable application and look to optimize further where the options are there in the silicon, like we have in the IMX RT500. That's an example you'll be able to see out there on the NXP site. For customers who want to see our contribution in hard numeric terms, you can look at the most recent release from March, which is release 4.1, and you can see that NXP was in the top 3 contributors there with about 10% of the pull requests.
So you mentioned that this customer demand has helped NXP invest more into the Zephyr project. Can you talk specifically about a few customer requirements that have influenced what NXP has actually contributed to the project?
Yeah, absolutely. One of the biggest drivers for our increased investment in Zephyr has been from direct feedback from customers requesting support. So I mentioned the distributed switch architecture request for comment we have out right now. That came from a customer looking to exploit the very specialized NetC switch we have in our IMX RT1180. The customers are looking to standardize on software platforms that give them more productivity without locking them into a single vendor, though. That's the bigger picture. We've seen a rapid move to this kind of approach since a bit of an inflection point that came out of this worldwide supply shortages that hit all the semiconductor vendors and their customers. And that was obviously a result of the COVID pandemic. And we've seen this big shift happening more rapidly than I've seen in my 12 years in the MCU space, where large OEMs are pushing to consolidate their products and move away from fragmented collections of different OSs and MCUs that they've built up over time through various project groups or inorganic growth by acquiring companies. Companies really want to consolidate on a smaller number of suppliers and make their software more portable. And customers are also attracted to open source RTOS choices, but they can be hesitant about the long-term viability of those. That's been a barrier before. And we've seen a lot of upheaval in the last few years where well-established RTOS have been acquired by large corporations who've then changed strategies or even divested the technology completely. So some other products are owned by small specialist companies who do a very, very good job, but they are small and inherently there is risk because of that. Plus, there's a cost involved. So while they can be very good, they're not free, and they may also lack the kind of middleware or a way to influence the middleware that's developed. So that's put off customers from taking the plunge of going very specifically to one RTOS choice. And as cybersecurity regulations are now upon us, that's become even more of a concern because companies have to think about their product being out there for at least 5 years and where they're going to go and get help when security issues come up. And so the beauty of well-supported open source projects like Zephyr is that they evolve based on the needs of the developer community and the members. And of course, that all depends on the community in question having critical mass and motivation. So you can have an open source project, but there's only one maintainer who has all the control or not enough companies to make it viable to actually move things forward, then nothing really happens. So we work closely with the customers, gather their feedback, and use that as input to help guide us on what we want to meaningfully contribute to Zephyr. So it's very much a collaborative effort, and we have frenemies in the project, companies we compete with that we join forces on to move forward for the common good. But one of the especially good things about Zephyr Project is members just aren't only software or semiconductor vendors, as I mentioned. It's the fact that we have these major OEMs who are often our customers from a range of different industries, and anyone can get involved and contribute to the project.
Very cool. Thanks, Brendon. And I'm going to shift gears just a little bit now. And I'd like to ask you, how does Zephyr align with NXP's very broad processing portfolio?
Yeah, it really is a perfect fit for NXP's broad range of embedded processing solutions, because one of our strengths is we have this great portfolio of devices. Whether you're looking at a flash-based micro or a crossover i.MX-RT processor without any on-chip flash, and a quite different architecture, Zephyr provides a unified software platform that allows developers to work across multiple NXP product families without having to start from scratch every time. The standardized APIs provide hardware abstraction. That means you don't have to refactor your code when moving from these quite different architectures and different underlying peripheral IP. Some customers are also choosing to scale up even to i.MX microprocessors where Linux or Android might just be overkill for what they need. Those OSs provide a huge amount of capabilities in terms of middleware and multi-threading and so on, but it may be you don't need that. You just want a very high performance microcontroller in effect. And Zephyr can be a really good solution for that. There could also be a need for predictable real-time performance, and that's really what's driving the customers to need to select an RTOS rather than Linux or Android. Some of these customers are even looking at scaling application software reuse from these i.MX devices down to i.MX-RT for cost reduction across their lower-end products. This is really possible for the first time with Zephyr OS. It has been done before, it could be done before, but it's a lot harder with the RTOSs that existed in the market before.
Okay, so you're really starting to talk about the hardware abstraction. You mentioned it a few times. So is the hardware abstraction really just down to having a standard API? And how is this different from what has been done by other RTOSs?
So the APIs are really at the heart of the code portability, because obviously you need to talk to hardware in a consistent way. But there are other features that also make moving applications between platforms far more efficient than just by having a hardware API defined like that. Since the project's open source, the API definition is as well, so it's not locked to a particular vendor. But most other RTOSs don't have a hardware abstraction layer like Zephyr does. The ones you see in the market are more typically driven by a semiconductor vendor and therefore are proprietary. So beyond that API, though, Zephyr also has the notion of device tree and K-config concepts, and that's going to be familiar to people who know Linux. The difference is in Linux, these are interpreted at runtime as opposed to at build time. So put simply, device tree is a configuration file that defines how you bind from a driver to the underlying hardware. And rather than needing to actually go and change your coding to match those things together, you do it with this configuration file. And there's some very cool things that have been developed by the Zephyr project to compile that using the preprocessor during build time. And so it's static. Linux gives you more flexibility because it does it at runtime, but there's a pretty high cost in terms of memory use and performance by doing that, which you can typically afford in a Linux system, but it's something you don't want to carry around for a microcontroller. Kconfig is another concept that also exists in Linux, and it's a defined way of enabling or disabling software features, again, by simply changing a configuration file and not having to touch the source code itself in order to enable or disable software features. So by using device tree and kconfig alone, you can move application code between different underlying platforms and not having to touch the actual source code to do that. There's definitely some fear in the market around device tree and it being a scary initial concept, but we've found very consistently that once people have got to grips with device tree and how to use it, they don't look back. They see massive benefits from going in that direction.
Very interesting. It sounds like there's a little bit of a learning curve with device tree and kconfig, but once developers get the hang of it, they're all in. So for developers just starting to explore Zephyr, what advice do you have for them as they dive into these features? And before we wrap up today, anything else you want to share with our listeners?
Yeah, I'd like to encourage developers to explore the Zephyr Project site and look at how Zephyr could really benefit their applications. The collaborative nature of the project means there's a wealth of resources and a very supportive community to assist. You can get on the Discord channel and ask questions, and there's a whole host of different engineers who are friendly and helpful to help you with advice. I'd also like to mention that our M2 Expresso for VS Code extension has been crafted to support Zephyr development, and the M2 Expresso installer that comes along with it also makes setup of the Zephyr environment super easy. That's one of the other challenges that people sometimes have, is because Zephyr uses Python and the versioning in Python can be a little bit tricky. You also need to install other things, build systems and so on to get it to work. But with the M2 Expresso installer, it's just a question of checking some boxes and hitting go, and then the environment's ready to go. We really want to give customers the best possible developer experience. So this is one of the key areas of focus for our IDE team. I personally enjoyed listening to one of our key guys from the team, Christian Tepes, who was a guest on the Tech Podcast just recently, right?
Yes, Christian was a recent guest and gave us a nice deep dive into MCU Expresso for Visual Studio Code and how it's been a game changer. It's great to see how NXP continues to enhance the developer experience, making tools like this so much more accessible and user-friendly. If you haven't checked out that episode yet, I highly recommend you give it a listen. It's a must for anyone looking to optimize their Zephyr development process.
Well, I think that's a wrap for today's episode. And a huge thank you to Brendon for joining us and sharing all your insights into the Zephyr project and how NXP is contributing. Thanks, Brendon.
Thanks, Brendon.
Well, thank you, guys. It's been a real pleasure being your guest, and I hope there wasn't too much BS.
Thank you to all of our listeners for tuning in. We hope you enjoyed this deep dive into the world of real-time operating systems as much as we did. Don't forget to like, subscribe, and set up notifications so you never miss an episode.
And again, if you've got ideas for future topics or you just want to provide feedback, feel free to add them in the comments section, because Bridgette and I would love to hear from you.
Until next time, keep innovating with us in the Edgeverse.